Okay, we are ready for Calc 11.1 Day 1 tutorial, where we're going to explore limits. So we all have an idea of having a limit, whether there's a limit to how tall people can grow or how fast people can run or swim. But this idea of limits in calculus, although it's similar, it's different. So let's look at what we mean when we talk about limits in calculus. So here we have a graph, and we're going to talk about finding the limit of this function f of x. So our graph that we see is the function f of x as x approaches 0. So note how I pronounce this. When you see this, you're going to say the limit of f of x, or whatever is after the limit, as x approaches 0. And so what this question is asking us to look at is look at the graph and see what's going on as x approaches 0. So another phrase to drop in instead of saying the limit of f of x as x approaches 0, you can say, hey, what's going on with this function as x is approaching 0? So we're going to look at x approaching 0 from two sides. Let's look at it first from the right side. If we were to start here where x is equal to 4, let me switch colors here. Let's say we were to start where x is equal to 4, and we start moving towards 0 this way. So we're looking at x equals 3, x equals 2. We can kind of see what's going on, right? As we're moving, x equals 1, as we're moving to the left, as x is getting closer, closer to 0, look what the function's doing. It's getting closer and closer to the y value of 1. So we're looking at the height. The height will always be our answer for our limit problems. So from the right, as x is getting closer and closer to 0, the y value is getting closer and closer to 1. It's approaching 1. So same thing when we approach from the left side. As we're looking at x is equal to -4, or x equals -3, or x equals -2, we notice that the corresponding y values, as we're moving closer and closer to 0, are getting taller and taller until they're approaching 1. So our limit of this function as x approaches 0 from both sides is going to equal 1. Once again, another way of saying is, hey, what's going on with this function as x is approaching 0 from both the left and the right? And the answer is 1. All right, let's look at another thing. Here we've got a interesting looking function. All of these graphs are going to look a little bit different than what we're used to. But here we're asking for the limit of this function as x approaches 2. So as we're looking from both the left and the right, when we come from the right, as x is getting smaller and smaller, approaching 2, we can see that the graph is going down, right? And it's leading towards a height of 3. You guys see that? So from the right, as x is getting smaller and smaller and approaching 2, the height of the graph is approaching 3. And so then when we come from the left, we see that as we're approaching 2 from the left, our graph is getting taller and taller, right? As x is moving closer and closer to 2, the corresponding y for all those x's is getting taller and taller, and it's also approaching 3. So the limit of this function as x approaches 2 is 3. One of the things that we talked about in class is, as you're approaching, like let's look back as we're approaching to the right. As you're approaching on the, looking at the axis as x is approaching 2, kind of think about it like a camera on wheels. All right, this does not look like a camera on wheels, but let's see. And the camera is looking, right? Looking to record. That looks like a bug or something. But anyways, it's looking to record what happens with the graph as it's moving this way. So that's another way to think about limits, is that as our camera is moving along the x-axis, it's recording, it is filming the action of what's going on with the graph. Now, this is a strange looking graph in that if I asked you to write what is f of 2, well, that would be different than the limit of this function as x approaches 2. Okay, and we'll talk about that later. All right, so here we've got what's going on with this function as x approaches 0. Once again, instead of saying limit of f of x as x approaches 0, you can say, hey, what's going on with this function as x is going to 0? Or another way of saying it is, what's going on with y as x is getting closer to 0 from the right and from the left? And you can see what's happening, right? As we get close to 0 coming in from the right, we see that the graph is going downward and it is coming towards 0. And as we move from the left, x is getting closer to 0, what's y doing? It's moving upward, and it's also heading to 0. So the limit of this function is equal to 0. All right, so let's look at this. We've got another graph of f of x. So it says, what's the limit of f of x as x approaches 1? Another way of saying it is, what's going on with y as x is approaching 1? So this one's a little different as we're approaching 1 from the right. As x is approaching 1 from the right, what is y doing? Well, we're looking at y as the height of the graph, and we can see that it's getting taller and taller, and as x is getting closer to 1, y is getting closer to 4. Okay? But now let's go ahead and look at it from the left. As x is approaching 1 from the left, what's going on with the height of the graph? What's going on with y, which is the height of the graph? It's getting taller and taller and taller, and from the left, it's approaching 2. We've never seen this before. When x approaches 1 from the right, y is approaching 4. As x is approaching 1 from the left, y is approaching 2. So you know what we write? What are we supposed to pick something in between? We can't put 2 and 4. So what we put is D and E. The limit does not exist. And in this little square in your notes, we're going to say y. It doesn't exist because, excuse me, f of x is approaching 2 different values. And when that happens, we don't have a limit. So what's happening with this function as x approaches 1, or what's happening with y as x approaches 1? Well, the function, the value of the function, which is y, is approaching 2 different numbers. So the limit does not exist, D and E. All right, so this looks very familiar, right? It's the same thing. As we approach 2 from the left, we can see that the function itself, f of x always stands for y, right? The same thing, is decreasing, and it's heading towards a value of, it looks like, 2. So coming from the left, as x is approaching 2, the y value is approaching 2 as well. Coming from the right, as x is approaching 2, the y value, f of x, is decreasing, and it's approaching 1. So they're not approaching the same thing like they were in our first few examples. And when that happens, we know it's right? We write does not exist, D and E. Also, we're going to go ahead and write, anytime we write D and E, we're going to write in parentheses Y. And we can shorten this. We can say approaches 2 different values. How about that? Approaches 2 different values. So maybe we could shorten it even more. Approaches 2 different values. We'll know what we mean. All right, so let's look at what's going on as what's going on with y, right? F of x is y. So what's going on with y as x is approaching 1. So once again, we look at from the right and we look from the left. So it's interesting as we come, here's 1, right? And as x is moving forward towards 1 from the right, interesting things are going on with y, right? Y is up here at 3, and then all of a sudden y jumps down here to a value of 2, and then all of a sudden y jumps here to 1. So as we're approaching 1 from the right, y's value is at 1. But as we're approaching 1 from the left, it's a totally different pattern, right? From the left, we've got y down here at -3, then -2, then -1. And as it's totally approaching 1 from the left, we see that it's approaching 0. So once again, this is another example of does not exist. And we can write two different, approaches two different values. Let's get that in there. So approaches two different values. So you may feel like, okay, Ms. over B, we get this. It's really good for your brain to keep seeing examples of something that's totally new to you. Don't worry, I'm going to give you time to practice this, but let's just go through these together and it'll help. All right, what's going on here is x approaches 0. This is crazy, right? From the left, it seems like y's value can't make up its mind, right? From the left, y is going up, then down, then up, then down, then up, then down, then up, then down. And it's doing the same thing as x is approaching 0 from the left, right? Y's value is decreasing, then increasing, then decreasing. It just can't make up its mind. So when this happens, we're never going to be able to settle on a limit, are we? So our limit of this function as x approaches 0 is not going to exist, but this time there's a different reason, and it's because y's value is oscillating. So we'll go ahead and just put oscillating. So oscillating like an oscillating fan, right, going back and forth and back and forth. And so that's what we'll put. Does not exist and oscillating, and I'm going to check on the time. Okay. Now let's look at another example here. Okay, just want to make sure I just kicked my mic, so I'm going to make sure everything's still in. Okay, so here, this function, we're looking at the graph, and we're wondering what's going on with y as x is approaching 2. So what's the limit of f of x as x is approaching 2? So when x is approaching 2 from the right, I see that y is getting taller and taller and taller, and there's no arrows, but it's implied, right? It's shooting up to infinity. And then when when x is approaching 2 from the left, what's y up to? Y is increasing, 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 also up to infinity. So the limit, it's going to be another limit does not exist, even though they're both approaching positive infinity. The only way a limit can exist is if from both the y's, from both directions, when x is approaching the x value from the right and from the left, and they both approach the same y value, can a limit exist? But here, infinity is not a value, right? It's just kind of more like a concept. And so we're going to say it does not exist, and it's because they're shooting up to positive infinity. All right, so here, as x is approaching 1, from the right, we can see that y is shooting off to positive infinity. And as x is approaching 1 from the left, we can see that y is shooting off to negative infinity. So the limit of this function, as x is approaching 1 from both the left and the right, is it doesn't exist. We're not approaching the same value from the left and the right. So it doesn't exist. And we can put the answer in parentheses that it's going off to both a plus and a minus infinity. All right, so in class we watched this pivotal scene from Mean Girls where she says the limit does not exist. All right, you can look that up again and watch it if you want to. All right, another opportunity to say, the limit of this doesn't exist, it's oscillating. And then this is just a reminder of the 3 different ways we discovered where a limit will not exist. So the first one, right, f of x approaches a different number from the right side than it does from the left side. So this is where we say approaches 2 different values. That's what we would write when this occurs. And the second one says increases or decreases without bound. So this is when the limit is approaching infinity or negative infinity. So we would write that either infinity or negative infinity, or sometimes, like in the other graph, we'd write a plus or minus infinity just to indicate why the limit doesn't exist. And the third way a limit doesn't exist is when it's oscillating. And so we would just simply write, after we write D and E, we would write oscillating. We'd write that in parentheses. So 3 ways that a limit of a function as x approaches a value won't exist. Either approaching 2 different values from the left and the right, or the graph shoots off to infinity or negative infinity, or even both, or the graph oscillates as x is getting closer to that value from the left and the right. Okay, at what x values would the limit not exist? This is kind of fun. Let's see. There's not an exact value, but it looks like maybe at -1.5. Yeah, if we put an asymptote, whoops, kind of bent it there. I think it's really supposed to be at -1.5, so we would say, what, at -3/2, and then there's another one that looks like at 1.5, right? If we did an asymptote down this way, that looks more believable. So at -3/2 and +3/2, the limit would not exist. And why? Because the graphs are shooting off to, f of x is shooting off to positive infinity or negative infinity. So limit would not exist there. All right, let's look here. At what x values would the limit not exist? Right here, right? Where x is equal to -2, because as we are approaching -2 from the left, y, the function, is approaching 0. But as we approach -2 from the right, as the x approaches -2 from the right, y is approaching -1. So we would say at -2, and we would, there's no limit, and we would say because it's approaching 2 different values. And same thing at where x equals 1, right? When x equals 1, they're also approaching 2 different values, so a limit would not exist. And I know what you guys are thinking. You guys are thinking, well, what about here at 1, 2, at 3? A limit does exist, even though there's this crazy dot up here, and this one is open. The limit does exist because we're looking at what y is doing in general. And y, as we move to the, as x approaches 3 from the left, y is moving down towards -2. And as x approaches 3 from the right, y is moving up towards 3. So there would be, or towards -2. So there would be a limit there. Okay, so now let's talk about the difference between f of x and, or a particular f of c. So a particular f of c versus the limit of f of x as x approaches some value c. So let's, if that didn't make sense, I think the example will. So let's look at the first thing. What is f of 1? That means if we go where x is equal to 1, what's the value of y? And we see an open circle here that clearly means no value there. There's nothing there. It's just like that open circle is like a placeholder. But here we see there's a value, there's a point. When x is equal to 1, y is equal to 3. So that's another way. Remember, f of 1 is a shortcut. Instead of having to say, hey, when x is equal to 1, y is equal to 3, we say f of 1. That means when x is equal to 1, the value of y is, and we say 3. All right, now let's talk about the limit, though, because the limit is not the same thing as the actual value at that x, right? It's not the same thing as the actual y value at the x. So we're more concerned with what's going on with y, what's happening as x is approaching 1. So as x is approaching 1 from the right, I see that y is decreasing and it's approaching 2. Same thing as x approaches 1 from the left, y is constant and it's just staying at 2. So the limit of this function as x approaches 1 is 2, but f of 1 is 3. And we're doing this, I know it might make your brain hurt, but we're doing this to show the difference between these two things, and we'll talk about that in the next few lessons. We'll make a big deal of this because it is a big deal. All right, so same thing. F of -1 means what's the value of y when x is equal to -1. When x is equal to -1, there's an open circle here. That's not a value, but there's a closed dot here that is a value. So when x is equal to -1, the graph, the y, is equal to 2. But now let's talk about the limit. The limit of this function as x approaches -1 from the left, we can see that as x approaches -1 from the left, the y, the value of the function, is moving up towards 1. And as we look at x approaching -1 from the right, we see that the graph is a constant. The y value is a constant, and it's moving, well, it's just staying at 2. So once again, do we have a limit of this function as x is approaching -1? We do not. We're going to write does not exist, because what's going on with y as x is approaching -1 from both sides? Y is approaching 2 different values. I'm trying to interchange y with f of x because that's really what f of x stands for, right? The value of y at a certain x. All right, what do you observe? Well, we observe there's a lot going on here at 1, right? When x equals 1, y equals 3, right? And we can write that as the value of the function when x is 1 is 3. But yet we also can see that the limit of this function as x approaches 1 is going to be different, right? As x is approaching 1 from the right, what's y up to? Well, y is getting taller and taller. It's approaching 4. What's going on as x approaches 1 from the left? Y is getting taller and taller, but it only approaches 2. So we know this does not exist because y is approaching, or f of x is approaching 2 different values. Okay, I'm not sure if these are on your notes. I think I probably used this in class to maybe do some marker boards. So we're going to be repeating ourselves over and over again, and I'm going to go ahead and skip this one. Don't believe it's in your notes. Okay, and here, what do you think is happening? This looks a little different. What do you think is happening as x is approaching 0? Y is definitely doing something, right? It looks like it's oscillating because it's going up, down, but this is a different kind of oscillating because it's actually, in its up, down movements, what's it approaching? You guessed it, it is approaching 0. From both sides, we can see it's up, down, but its up, down movements are restricted until it really is approaching 0. So a limit would exist there. Okay, so f of 50, and okay, so let's look at this. The value of the function when x is equal to 50 is right here at 8. The value of the function as x is approaching 50 from the right, it's approaching, y is approaching 8, but from the left, as x gets closer to 50, y is approaching 10. So the limit does not exist. Are we going to get tired of writing D and E and then approaches 2 different values? I don't know. Maybe if we get tired of it, that means that we know it really well. All right, so another what do you observe? We had fun with this in class. If you want to pause this and observe some things yourself, then you can. Okay, so now that we rock at finding the limit graphically, let's find it numerically. I just filled this out in my notes, so I'm going to pause, and I will be right back with the answers for these because I don't want to waste your time. Let's see, I'm going to pause and be right back. Okay, and so I'm picking up your calculator and plugging 1.9 into, all right, where did I'm speaking in my, there we go. Okay, so plugging 1.9 into the function. So you're plugging 1.9 in every time you see x. You're going to get negative 3.89. I'm going to do the same thing, plugging 1.99 into this function. You're going to get negative 3.989. And plugging 1.99 in, you're going to get negative 3.99. So what am I doing here? We're using, when we're just given an equation, we're going to use a table to help us figure out what the limit would be. So graphically, it was really easy to approach for x to approach 2 graphically, right? Well, we're doing the same thing now, but we're doing it numerically with a table. And so when we approach 2 from the left, right, think about, we could approach 2 from the left. We could say 0, 1, 2, there we are, we're there. But what we want to do in these tables is get really super close to 2 and then get even closer and closer. That's why we picked 1.9. Well, we didn't pick it. Somebody put this, well, I did. The table's just there waiting for you. I believe you'll always have a table that's set up for you, but that's the reason why we start really close to 2, 1.9. And then we try to get even closer to 2 by adding another 9, another 9, another 9, right? We could keep this up and do 1.9999 and 1.99999, but this is all we need to see the pattern of what's going on with y as x gets closer and closer to 2 from the left. So we plugged in the 1.9, we see we got negative 3.89, and then we plug the next thing. What are we approaching? It looks like as x is approaching 2, the limit of our function is approaching negative 4. That's what it looks like. So let's see if it's doing the same thing coming from the right. So once again, to set up the x coming into 2 from the right, I could say, oh, let's come in from 5, 4, 3, 2, we got there. That's not the way the tables are set up. How the tables are set up is they're like, get as close as you can to 2 from the right. 2.1 is pretty darn close, right? Now get even closer. 2.01. Oh, get even closer. 2.001, right? We could do 2.000000001, and then we're really close to it. We're approaching 2, but not equal to 2. So when we put our 2.1 into our function of x squared minus 5x plus 2, we're going to get negative 4.09. And when we put 2.01 in, we'll get negative 4.0001. And then, should that be a 9, I'm wondering? I have a feeling that should probably be a 1. But anyways, let's keep going. And then when we plug that in, negative 4.001. All right, so from the opposite direction, y, the function, is approaching negative 4, both from the left and the right, which means the limit of this particular quadratic function as x approaches 2 is equal to negative 4. So that's just another way to do it. If we're given an equation and not a graph, we're going to use a table to help see what happens as we move from the left and the right. All right, I think we've got one more to do with this, and oh, and there's a table without anything. So let's go ahead and fill that in. We're going to want to do, if we're approaching 4, think about 4 in a number line, right? So think about approaching from the left and from the right. So from the left, I think about 3. 3 is really, really close, right? Nope, we need to start even closer. How about 3.9? Oh, you want to get closer to 4? Yeah, me too. 3.99. Even closer? 3.999. Okay, so then let's go ahead and approach 4 from the right. You know, coming from the right, 5 is pretty close, right? No, you want to get closer? Okay, how about there? How about 4.1? That's pretty darn close to 4 from the right, right? Okay, let's go closer. 4.01 and 4.001. So you can see as we're moving towards 4 from the right, we're getting closer and closer. X is getting closer and closer to 4. And as X is moving towards 4 from the left, we're also getting closer and closer. So you want to pick up your calculator and start plugging these in. I know it's time consuming, but this is the way we find the limit of a function numerically. I'm going to pull this up. I think it will show up in the video. That's my hope. And there it is. As we're approaching, as x is approaching 4 from the left, y is doing some interesting things, right? F of x is going -10, -100, -1,000. Oh no, f of x is heading off to -infinity. All right, let's look on the right. As x is approaching 4 from the right, look what y is doing. F of x is 10, 100, 1,000. Wow, it looks like from the right, y, f of x, the value of y, f of x, is approaching infinity. So the limit of this function as we're approaching, as x is approaching 4 from the left and the right, is not going to exist, right? Because from the left, it's shooting down to -infinity, and from the right, it's shooting up to +infinity. All right, so we would write does not exist, and we would write plus or minus infinity to remind ourselves of why it doesn't exist. Okay, and that was our limit tutorial. You've got a pretty direct, quick homework sheet to do, and you'll find your the answer key on the blog. Hope you get a little laugh out of this, you know, limit homework, not limit homework, ha ha ha. Okay, see you next tutorial. Hey, and congrats on your first calculus lesson. You guys did great. See you next time.